Hello amigos, welcome to my channel Chemistry Unboxed. Today we are here with one more important topic which is limiting reagent. The question with which we have to start today's discussion is what is a limiting reagent? I repeat, the question says what is a limiting reagent? So to answer this, first let us look at the textbook definition of what is a limiting reagent. So listen, so the limiting reagent according to textbook is the reactant which completely consumed in a chemical reaction. That means in a chemical reaction, limiting reagent is said to be called, or the limiting reagent is called that reactant which is completely consumed in a chemical reaction. Okay. To understand this better, let us take an example of a chemical reaction. Suppose we have this formation of ammonia from hydrogen, isn't it? So there is this formation of ammonia from hydrogen and nitrogen. So when N2 reacts with 3 molecules of or 3 moles of hydrogen, we get 2 moles of ammonia. Now, if you look here, from the balanced chemical reaction, the information what we are getting here is 1 mole of nitrogen is reacting with 3 moles of hydrogen and to produce 2 moles of ammonia. I repeat, from the balanced chemical reaction, the information which we are getting is 1 mole of nitrogen is reacting with 3 moles of hydrogen to produce 2 moles of ammonia, isn't it? Suppose, think of this in this terms. Suppose, what if I want to produce double the amount of ammonia produced in this reaction? I repeat, suppose here we have production of 2 moles of ammonia. What if I want 4 moles of ammonia? What I'm supposed to do? I have to double the amount of reactants as well, isn't it? That means suppose instead of 1 mole, if I take 2 moles of nitrogen along with 6 moles of hydrogen, what do I get? I get 4 moles of ammonia. Yes or no? Fine. That means when reactants are given in equal proportions or required proportions, you will be getting the amount of product based on the balanced chemical reaction, isn't it? Now what if reactants are not in the required proportions? What if one of them is excess and other reactant is not? For example, again we are taking the example of same reaction, and here suppose uh, I'm taking 1 mole of nitrogen and now I'm taking 4 moles of hydrogen. Do you get it? I'm saying we are taking 1 mole of nitrogen and 4 moles of hydrogen at the starting of reaction. Now, during reaction, what happens? We know from balanced chemical reaction, what information are we getting? 1 mole of nitrogen reacts with 3 moles of hydrogen. That means this 1 mole completely reacts with 3 moles of hydrogen. So, if nitrogen is completely reacted, we are left with 0 because no reactant is left. But what about hydrogen? Out of these 4 moles, only 3 moles react with 1 mole of nitrogen. That means, can we say another mole of hydrogen is in excess? Isn't it? So, what is happening here is my nitrogen is getting completely consumed, whereas hydrogen, which is in excess, is still left out, isn't it? Is still left over some amount. Now, what are the product found? We know whenever 1 mole of nitrogen reacts with 3 moles of hydrogen, you have to get 2 moles of ammonia. Yes, yes. That means, can we deduce that product formed depends upon the limiting reagent, isn't it? Here, what which one is limiting reagent? During reaction, which is getting completely consumed, it is nitrogen, isn't it? We are starting with 1 mole, it is left, it is completely consumed, 0 moles, but hydrogen is still left, isn't it? That means the reactant which is in excess, like hydrogen here, is can never be called as limiting reagent. And if you remember the definition says the reactant which is getting consumed completely in a chemical reaction is what is called as limiting reagent. And if you remember, if you look at here, even though we have excess of hydrogen, still the amount of product found is only 2 moles. That means, can we say it is the limiting reagent which decides the amount of product formed? Isn't it? That means even though we have hydrogen in larger amount, still that excess amount of hydrogen is still useless. Why? Because there is no nitrogen available for this amount to react with nitrogen. That means in a chemical reaction, the product form depends upon the or the amount of product form depends upon the limiting reagent. So we have this famous application of limiting reagent which says during a chemical reaction, it is the limiting reagent which decides the amount of product formed. I repeat, very very important. During a chemical reaction, whenever you are interested in finding the amount of product formed, the first question you have to ask is which is limiting reagent. Because if you know which one is limiting reagent, that decides the amount of how much of product is formed. The other reactant whichsoever is in excess is of no use. That excess of reactant will be of no use for us, isn't it? So please remember this, very very important. What is it? In a chemical reaction, the limiting reagent decides the amount of product form. But why is that? How a limiting reagent is deciding the product form? Let us understand this particular statement with the help of analogy. For example, I have a shirt and I have a trouser. So when we have one shirt and one pant, isn't it? We can make one pair. We have one pair of shirt and pant. Now suppose what if I have two shirts and two pants? Then how many pairs do I get? How many? Yes, I get two pairs of, isn't it? I get two pairs. Now suppose we have a situation where you have three shirts and two pants. Then how many pairs you can make? Yes, I have three shirts and I have only two pants. So how many pairs we can make? Obviously we can make only two pairs, isn't it? One here, one here. That means this shirt which is in excess is of no use for us because we cannot pair it with any other pant. That means can we say even though we have three shirts, but the number of pairs can be made is only two. Why? Because pants got finished. Isn't we don't have extra trousers. So with this means whichsoever is in lesser quantity, that decides how much of final product is formed. Same with the previous example. Their nitrogen is getting consumed. So the amount of product formed depends only on the nitrogen. That means in any chemical reaction, the amount of product formed depends only on the limiting reagent. I hope I'm clear. Okay. But the question is, in a chemical reaction, how do I know? So sorry, this was done. Now the question arises: how to find a limiting reagent? Okay. How to find a limiting reagent? So the question to ponder over is: in a chemical reaction, when different chemical reactions are given, or when complex chemical reactions are given, how do you find which one is our limiting reagent, or which of our reactants is a limiting reagent? So to help us with this, we have the statement which says the reactant with lower value of stoichiometric amount will be the limiting reagent. What is it? The reactant with lower value of stoichiometric amount will be the limiting reagent. Fine. So that means whichever is having lesser stoichiometric amount, that is our limiting reagent. But the question arises, how do we find limiting stoichiometric amount? How to find stoichiometric amount? So to do this, we have this small trick which helps us in calculating stoichiometric amount. So what is stoichiometric amount? Amount is simply the ratio of given amount of reactant. It is simply the ratio of given amount of reactant upon participating amount. How do you get the given amount? It is the amount which is mentioned in the problem. So you'll be told how much of each reactant is reacting. And participating amount is the information which you get from a balanced chemical reaction. Okay, I repeat. How do you find stoichiometric amount? It is the given amount of reactant upon participating amount of reactant. So to understand this better, let us take help of a question. Okay, we'll solve this question. Through this question, we'll understand what is the limiting reagent and how do we find that. So the question says a steel vessel containing 10 grams of hydrogen and 64 grams of oxygen was exploded. That means here 10 grams of hydrogen is reacting with 64 grams of oxygen. And the question says when this happens, how many moles of H2O is formed? I have told you earlier, whenever questions on the amount of product is formed asked, first thing we have to do is to find the limiting reagent. Okay, so we have this balanced chemical reaction which involves a reaction of H2 with O2, and the product is always water, isn't it? So since now they gave us 10 grams of hydrogen and 64 grams of oxygen. Now they're asking how much of water is formed. As I told you, to calculate this or to find the limiting reagent, first we have to calculate the stoichiometric amount. And how do we do that? With the help of given amount upon participating amount. So I have three quantities. One is given amount, then participating amount, then stoichiometric amount. From the problem, given amount is 10 grams of hydrogen and oxygen is 64 grams. And from balanced chemical reaction, we have to obtain the participating amount. So in the chemical reaction, we have 2 moles of hydrogen which implies we are having 4 grams of hydrogen, isn't it? One H2 molecule weighs 2 grams. Since we are having 2 moles, now we have 4 grams of hydrogen. And the amount of oxygen, which is participating in a chemical reaction, is 32 grams because 1 mole of O2. So we have obtained given amount, we have obtained participating amount. Then calculation of stoichiometric amount should not be of any problem. Why? We simply take the ratio of given amount upon participating amount, given amount upon participating amount. So the stoichiometric amount of hydrogen is 2.5. How? 10 by 4, given amount upon participating amount. And the stoichiometric amount of water will be simply 64 by 32, isn't it? It's 2. So if you look here, if I compare stoichiometric amounts of hydrogen and oxygen, which is lower? Oxygen is lower. That means 2.5 is greater than 2, which implies hydrogen stoichiometric amount is slightly greater when compared to oxygen. That means can we say here oxygen is the limiting reagent in this chemical reaction since oxygen stoichiometric amount is less. That means oxygen is limiting reagent. Okay, so we got our limiting reagent which is oxygen. Now the question says how many moles of H2O is formed? As I told you, it is the limiting reagent which decides the amount of product formed. So let's calculate how much of water is formed. So this we already know, isn't it? The chemical reaction, it is a limiting reagent which decides the amount of product formed. Now we are supposed to calculate how much of water is formed. So we have this reaction 2H2 reacting with O2 and gives us 2H2O. And from the balanced chemical reaction, what do we know? 32 grams of oxygen produces 2 into 18 grams of oxygen, which is 36 grams of oxygen. 32 grams of oxygen produces 36 grams of oxygen. Now, from the question, what do we have? We are given 64 grams of oxygen. And we know oxygen is the limiting reagent. So this should decide how much of water is formed. So we have to calculate how much water is formed. So now what do? I'll apply unitary method and I'll do cross multiplication, which is x into 32 is equals to 64 into 36. So what will be the value of x? 64 by 36 upon 32. So we have 32 two times. So total we have 72 grams of H2O being produced. So when I have 10 grams of hydrogen and 64 grams of oxygen, how much of water is produced? 72 grams. Why? Because we have 64 grams of oxygen, which is our limiting reagent. So if you look at the options, if I go back to the question, so the question says how many moles of H2 is formed? So yes, now we are trying to find how much of water is formed from oxygen. So if I start with balanced chemical reaction, we have hydrogen reacting water and to give 2H2. Now we just got to know oxygen is our limiting reagent. So how much oxygen we have? From the balanced chemical reaction, the reaction says we have 32 grams of oxygen and produces 36 grams of O2. Why? 2 moles. 2 moles means 2 into 18 grams. Okay. That means when I have 32 grams of oxygen, we get 86 grams of 36 grams of H2O. But the question relates, the question is asked based on the how many moles of H2O is formed. So then what do? Instead of taking weight of H2O, I'll take number of moles of H2O, which is 2 moles. So when I'm having 32 grams of O2, I get 2 moles of H2O. But in the problem given, we are starting with 64 grams of oxygen. Now they're asking how many moles of water is formed. I'll apply unitary method. So what do? I simply cross multiply them. So x into 32 is equals to 2 into 64. So what is x? 2 into 64 upon 32, which is 4 moles. That means when we are having 64 grams of oxygen, 4 moles of H2O is formed. So if I go back to the question, okay, look at the options. So we have 4 here, isn't it? So we have 4 here. I hope I'm clear. This is how we find limiting reagent. Thank you.